Hey, welcome to the Rustacean Station podcast. I'm here live at RustFest. I will continue to misuse the word live until someone stops me. I am here with Jake. I didn't get the last name, Jake.
Shadle.
Jake Shadle, with Embark, one of the sponsors of RustFest. And I came to RustFest and I saw this great big banner just with the words Embark, like over a night sky, and an astronaut looking like longingly at the stars with no other information about what Embark actually does. And apparently they are some kind of game development company, which I thought to myself, I must interview one of these people because it's a very game development in Rust is actually one of the longest like hobbyist use cases in Rust. I can think of like Piston as one of the oldest like big Rust projects. Yeah. Still ongoing as far as I know, but like apparently you have actual like AAA industry experience, and you come from that background. And so I wanted to kind of talk today about just like your background in, I presume, C++, what got you into Rust, how like ready or not ready you think Rust is for this kind of field. But let's not get into that too quick. So you are Jake, and you are, yes. What's your experience in AAA games?
So I've been working in games for about 12 and a half years, a little bit in a couple of years in Austin, Texas, and then I moved to Sweden and worked at Frostbite, EA's internal engine for most of the games now, and worked there for like 6 years before joining Embark and actually earlier this year, like January, and Embark just celebrated its like 1 year anniversary on Friday. So we're a pretty young studio made up mostly of former DICE people, but also other people around Stockholm and Europe in general.
And in case people know video games but not what Frostbite is, can you name some games that use Frostbite?
Well, Battlefield is the big one. Battlefront, the Star Wars,
which is a lovely game.
Need for Speed,
visually very impressive.
Yeah, it's been known throughout the industry for its high graphical fidelity, which is annoying because a lot of people call it a graphics engine, which it does way more than that. Mm-hmm. But yeah, so basically I've been working with Rust. There is some Rust code in Frostbite. I don't know how many people know that still that work there, but there is a bit of it. And I just was drawn to the language for, the typical reasons of safety and all the stuff that I like from C++, but don't like about it. So
choosing your words carefully there.
Yeah. So I've been using it like kind of internally, like on like personal projects and stuff. And then the opportunity came to work at Embark, and our CTO, who's also former Frostbite, was, had picked up Rust earlier and was like, this is a great language and I want to use it. And so it became like our primary language for our long-term projects. We're also doing like other projects right now in Unreal, so those are still C++, but yeah, like Rust is our kind of long-term future.
Okay, so the plan is to entirely rewrite Frostbite in Rust. Rustbite.
No, because then we would get sued or something.
Oh, that's true.
Yeah, but no, I mean we're kind of making a game engine, but not really a game engine. We'll share more as we get more. But
sure,
right now
I don't want to press you for too many details. Just say it seems like you're still in the initial phases.
Yeah, we're still very, very early.
I wanted to get your impressions on Rust as a language. You mentioned you like the safety aspect of it. I know that what I've heard in the past, especially like when Rust was very young, was that like game developers especially, they care more about iteration speed than about memory safety. What's your opinion on that?
Yeah, so I mean, iteration speed is definitely very important, and like there are a lot of good things that you get out of faster iteration because you can try out more ideas and all that kind of stuff. But at the same time, like when you're shipping a game, typically the thing that you're doing at the end is optimizing performance, but also tracking on that one bug that you've had for like 2 years that has never been like such a big problem that you need to fix it, but is now shipping out to hopefully millions of people, and you do need to fix it. and like data races, and that's like just getting worse over time because previously you would maybe have like 2 threads on the CPU to actually do anything, so it wasn't like a huge issue to have data races and stuff because they weren't very frequent. But now that you have to have more and more threads to actually be able to do anything, at least on the CPU, means that you're going to have more and more problems that come with that. So Rust kind of eliminating whole classes of bugs just means you can spend more time on the things that actually matter. And to me, the trade-off is definitely worth it. In my opinion, the differences between C++ and Rust compile times for equivalent code, that's really hard to define, which is why you can't really do a one-to-one comparison. But it's to me, they're not really that wildly different. So yeah, I'll definitely take a similar compile time for way fewer debugging hours in the future.
Talking about parallel stuff, how thoroughly parallel is an engine like Frostbite? In terms of is it a few threads? Is it 1,000 threads?
So Frostbite's super complicated. It has pretty advanced thread scheduling, and it has a whole job graph, a job manager that basically has a graph of tasks that you're rendering in a frame is generally 16 milliseconds or less. So you have to do thousands, tens of thousands of things in 16 milliseconds every single minute, every single hour. So it's pretty intense, and a lot of work was put into it and is being put into it. It's a really hard problem. We've actually talked, that's another thing that kind of Rust doesn't really have a good story for at the moment. It has really nice, rayon and crossbeam and stuff are really, really good, but they're not really made for games.
Okay, in what way? Low latency?
Well, it's just there's certain things that you have in games that kind of are so one example would be a linear frame allocator, where you have this nice advantage of if you just have a linear bump allocator, so you can just do a bunch of allocations that are super fast because they're pre-allocated, and then that you're going to say dispatch to the GPU, if you're doing draw calls. And so you can allocate a bunch of stuff, but then you have this convenience where once the thing has been pushed to the GPU, you can deallocate that memory, but instead of deallocating it and doing cleanup and all that kind of stuff, you just reset the pointer to the beginning and then start again the next frame. And that's something that you can't do in a general purpose thing, but because you're in a game, you have the all the context and stuff. So certain things like that, I think will percolate into Rust and more of the general libraries as more and more games start being used. And that's one of the things that we've been doing for months is basically for certain crates that we use, getting our use case in or improving it so that we can do what we want with it. And that's just a lot of work, but that's also why we sponsor things like Amethyst, because
very cool.
Even though we don't use Amethyst ourselves, if they improve a crate for them, that's maybe also improving it for us, and so it's well worth the money that we get them.
And what kind of crates do you use? Can you name some?
Oh yeah. Well, so
what are your favorite crates that you use?
What are our favorite crates?
Open source public crates.
Yeah. Well, we have our least favorite crate is probably OpenSSL.
Okay.
We'll say that. Let's see. What's our favorite crate? We use a lot of the classics, I guess, like Surdy and
any that are specific to game design or maybe
anything
people haven't
specific.
Heard of?
Right now, not really. I don't think. I can't think of any off the top of my head.
Which crates were you forking to add in this kind of bump allocator support?
We haven't. Well, we didn't fork any crates for that yet, but that kind of stuff, we will be adding more into and all that kind of things. But most of the stuff that we've open sourced so far have been tools that we've developed, and then also a lot of pull requests to like bump versions and make things easier to use and things like that. But yeah, what is our favorite? Yeah, I don't know. We're doing a lot of like current stuff like HTTP and SERDI and things like that. So yeah, we're using like request because it's pretty nice. And oh yeah, we're also using Tonic, the gRPC thing that's still in alpha, I think, but is going to be hopefully released officially pretty soon.
What does the game engine want to use a gRPC or HTTP for?
Well, so we're not really doing like a game engine in the traditional sense, like a Unreal or a Unity or anything like that. It's more of a toolkit for other people to make games. So yeah, it's not going to be the same kind of constraints that a game engine has, and then also like we'll be pulling in like services in the cloud and things like that. So there's going to be a lot of interaction between different components and stuff. And then like one thing like we're really interested in is WASM. That's actually like one of the top 3 reasons to use Rust right now for games and specifically is because WASM is like, and Rust are just like a really great fit right now. Like Rust is easily the best language for doing WASM because not only is it compiled to WASM, but like all of the most of the great WASM runtimes like Wasmer, WASMtime are all written in Rust. So like there's a really nice ecosystem around that right now that we're really interested in.
Are there any WASM crates that you can talk about that you like a lot?
Yeah, I mean, right now, like I said, we're using Wasmer for our runtime, and it is really quite good.
What is Wasmer? Just like
so So WASMtime is kind of Firefox's or Mozilla's Wasmer runtime to load WASM binaries and execute them in a sandbox. Wasmer is a different one that still has a lot of the same features and stuff, but it, like for us, WASMtime at the time didn't have good Windows support. But I think that's hopefully getting better now. But yeah, Wasmer is another kind of alternative runtime.
So this would let you actually run WASM compiled applications outside of the browser? Is that the idea?
Yes, outside of the browser. Yeah.
Okay.
So
why would you want to do that?
Because browsers have a lot of restrictions, and those are sometimes, when you're browsing the web, they're good restrictions, but when you're wanting to have a high performance application, they're maybe not so good. So we're doing, basically right now we have like Vulkan and WASM in a desktop app for Linux, Mac, and Windows. And so we can do high performance desktop stuff, but also have the guarantees of WASM. So it's like a really nice way to have small sandbox code to do things that you don't have to trust and can be from whoever.
Great. Okay, that sounds fantastic.
Yeah.
So do you think you'll have anything to show anytime soon with regard to like an actual like
a
Pong clone that we can run? Is that
yeah, so we have been working recently on this idea of like getting our stuff into a state where we can like hopefully send a tweet out with like a link, and then you can actually download the client, and then the link is actually a deep link into the application, and so you can like, we don't know what we're going to release yet. We have like a lot of stuff, but like we're trying to like find actually the best thing to release, and we might get it before the end of the year or early next year. We'll have something hopefully to show.
Okay, very cool. All right.
Yeah.
Well, thanks for talking to me, Jake.
No problem.
If people wanted to get in touch with you or learn more about Embark, is there any kind of website you want to point them to, or chat channel, or?
Yeah, so I think the best site that we have is embark.dev, and that basically has links to all of our open source projects, links to like the sponsorships that we're doing through like GitHub sponsors and Patreon and all those kind of things. And then I think it also probably will have email links and stuff to us so that you can open a communication channel.
Great. Well, thanks so much. I'll let you get back to whatever you were doing before I grabbed you by the collar and drag you in here.
Yeah.
All right.
Awesome. Thanks.
Welcome to Rustacean Station. I'm Ben Striegel here live at RustFest. No one has yet stopped me from using the word live on these clearly pre-recorded episodes. I will continue to do so. I am here now with Yoshua Wuyts.
Yeah.
Did I get that correct? Why don't you say it yourself so that everyone knows?
Yoshua Wuyts.
Wuyts. I see.
That's Dutch.
Dutch. Excellent. Oh, that's where we were having a RustFest next year, I hear.
Yeah, I'm very excited for that.
Oh, yeah. Is it in Amsterdam? They didn't say the city.
No, they haven't.
Okay, curious.
I'm hoping not.
No?
It's always in Amsterdam.
But, like, I want to go there really bad. I need an excuse to.
Well, we'll see.
Anyway, so you are a contributor to async-std.
Yes.
And I wanted to, it's a big topic right now, async stuff. And so for me, I know it was a talk from Florian today at RustFest, kind of going over what async-std is and does, but still, I want to talk more about the broader, like, high-level stuff where, for example, if I'm just, like, writing, and it seemed almost like they wanted you to never have to import std at all. And so does async-std, for example, export like things like option, which you wouldn't ever think would need to care about futures, which I hope not. Does it?
Well, you'd be surprised.
Oh, surprise me.
Well, option implements iterator, right? And we have an asynchronous version of iterator called stream. So in a perfect world, or, well, it doesn't implement, so it implements into iterator, so you can convert an option into an iterator, which is nice when you're combining things. We may someday want to implement into stream for it and have its own, like, dedicated stream type, so we might export option at some point.
That's a good point. So in terms of, like, I can pinpoint kind of, I'm still working on the async ecosystem, because I was kind of like trying not to look at it until it was stable, and it's kind of getting there. And maybe now I'm just want to learn about it, which I figure plenty of folks are in the same boat. And so I can think, okay, of a few things where it's like stream seems like a pretty fundamental piece.
Yeah.
Would that be kind of like, would that go next to futures, say, in the futures standard library? Like someday. Like,
right.
I guess let me back up. Do you feel like there are things from async-std that should go into actual std? Like they actually belong there.
That's a very interesting question. So I think the things that are closest to being merged into std are part of what is called the futures core library.
That's futures.r or futures-rs.
Yeah, futures-rs. And the library is split up into multiple parts. Most people, they use the futures library. So put futures in your cargo toml. But there's another library, which is like the core parts of that, called futures-core, which is now also 0.3.1, I believe now. And the future trait used to be part of that, but it's moved into core. And there's a few others, but the most predominant one, the one that everyone is using and seems to be agreeing on, is the shape of the stream trait.
Stream, okay.
Yeah, so I think that would indeed be something.
I'm not sure how like in tune you are with like Rust development, with the library team, that kind of thing, but do you feel like in the next year or so stream might be accepted, or you're not quite optimistic, or you don't want to say?
So it's hard for me to like gauge whether or not something will happen, because oftentimes you need to put an RFC and people have opinions,
and there isn't even an RFC for all I know for this kind of thing. So
but I think everyone in the ecosystem is agreeing on the shape of this. And if everyone's agreeing on that, then it seems logical to at least start putting it into nightlies.
Great.
So I would like to see it.
Because I was looking at a few things today in Florian's presentation. It seemed like stream, some things were pretty cool with that. And I know for a long time people have asked for kind of streaming iterators as a concept. And I'm not sure if that if they were using streaming in the same way that you are.
No.
Okay.
So confusingly, the phrase streaming iterator could also be called iterable iterator. It's something with borrows and lifetimes. So, damn it. I don't really want to get into the details, but it's used differently.
We're here about async stuff. But anyway, so actually, so what you go back to the async-std, like, so the option example. So there are, like, for example, plenty of std types that actually do want to have, like, certain maybe not, I'm not sure if you export option from that crate, but they want to implement things for option. And if the stream trait is from futures, and you have to wrap something to get around coherence?
No, not quite. You're asking like all the questions that are like, well, let me break it down into this sort of murky explanation.
I'm here all day. Go ahead.
Yeah. No, so what you really like is for certain types, such as string. So all right. So a very nice thing you can do with iterators is you can collect. So you have an iterator, and then you do a map or something, and you say, okay, cool. Now let's collect all this stuff back into a vec or a result of a vec or back into a string, right? There's all these types. And the way this mechanism works is something like a vec of t implements from iterator, and then you can be like, okay, cool. So from an iterator into a vec, there's a transition path there, right? Now it's very nice to have an asynchronous version of this. Imagine you're doing a bunch of calls to a database, right? So you get a bunch of like queries or something, you do some transformation on it, and then you say like, cool, let's write this list of structs or whatever back into like an array, and then let's continue from there, or a vector or whatever, right? So having an asynchronous version of into stream and from stream is extremely useful, next to having like the stream trait. Unfortunately, these are not defined in the core stream or in the core in the futures core library yet.
Okay,
that's an invention that we've come up with.
So async-std defines these from stream traits.
Exactly.
Okay.
And due to coherence, we can implement it one way, namely we can make collect work, but we can't say, for example, here's a vec of numbers dot into stream. Mm-hmm. So that would indeed require for these traits to go into the futures core library and then move from there. But I'm optimistic that we might.
It's good to have upgrade paths where it's like, the community experiments with sometime with some kind of thing, and then it gradually becomes more and more like goes from de facto stable to de jure stable, which is a pretty decent way of doing things, I think.
We've seen a really fun one there recently where we looked at I guess someone pointed out to us that in the RFC for async await, there was a mention of an into future trait that would be accepted. And we were like, oh, that's nice. Cool, let's add it to async-std, right? And then someone from a Tokyo project, or I wrote a blog post about it, and someone from a Tokyo project saw it and was like, yeah, that's indeed really nice. And they put in the work to put it into not just futures core, but they just went straight to a compiler and were like, hey, here's a thing, and here's a patch. And now it's, I think, either being merged or already merged.
Nice.
So yeah, like we're all building these things. That's really cool.
And I guess kind of the broader theme here is now that async await is stable, it's kind of maybe back when like the future trait was stabilized earlier this year since summertime. People were like, now we can finally use futures on Rust. We're kind of like, well, not really. You still gotta wait for a while. And now it's kind of like, oh, async await is here. Everyone's making a big fanfare of it. Can I use it now? Well, it depends on what it seems like when do you feel like the state of like Rust itself and all the foundational libraries are going to be such that people can just, without having to like worry about things breaking under them or too much like changing, like when is it going to be actually great? Do you feel like, is it almost there? Is it really far away?
Yeah, so we're really close. I think we're mostly there. The two biggest things that we're sort of waiting on to be built at all. Did you hear it? Yeah. All right. So something just went through the headset. Sorry. But yeah, the two things that we're like waiting on really is async closures, which are useful so you can borrow into a closure and give the borrow back, because you can't do that with closures and the async thing. And async traits, because implementing a trait requires an associated future type that you return as a parameter. It's very complicated. It would be really nice. Once these things truly exist, then almost all of synchronous ergonomic Rust would be expressible in asynchronous Rust as well.
Yeah, I've heard about async trait, and I can't think of right now. We have the David Tolnay has a crate where you can fake it.
Yeah,
where you put this attribute on a trait method or in an impl, or maybe both, I forget, and then it implicitly boxes things, but it looks real nice.
Exactly.
But I haven't heard much about async closures. It sounds like it would have been part of the original async await RFC. Is that just not implemented? Is it accepted?
So it used to be. Actually, it used to be part of the same feature flag, the async await feature flag. And then it was decided that it wasn't ready to stabilize yet because of it just wasn't. So it's been moved to its own feature flag called async closure. And what... it's a separate feature. So the sort of the idea there is, imagine you have an iterator and you would like to call filter on it, but an asynchronous filter. So you don't consume the item, you get a borrow into the item, and then you say, well, should this be continued, yes or no? So you return a bool. That in asynchronous form, you can't give the borrowed item into an async filter, just doesn't work today. So async and there's a few more, like an async version of map, I'm doing a shitty job explaining there. But there's a lot of patterns that we're still waiting on that are just not there.
I'm supposed to ask one more kind of like nitty gritty question in this area. I know there's there's the FN trait, there's the FN move trait, there's the FN once trait, and the FN mute trait. Would that involve a new like FN async trait or something?
So I haven't talked to the Lang team about this, and so this is not me having inside information. This is just me like being like, I think the answer is yes to all three of them. We'd have async versions of all three.
Or you'd have like an async move FN and then async mute FN.
Yeah, exactly. Async FN, async FN once, async FN mute. I think. But a cool thing, I think, again, I might be entirely wrong because I haven't talked to the Lang team. And they prove me wrong all the time. So, but you could implement these for synchronous closures as well. So you could have a function called map that you can give an async closure, but you can also give a synchronous closure, because going from a synchronous to an asynchronous closure is just wrap it inside of an async block. So that's a very easy upgrade path. So yeah, once we have those, that would be very nice. If this could work, it'd be great.
Is the async await RFC still up to date with this kind of design, or is it going to be like when they destabilized or made it its own feature, do they kind of say, hey, we're going to rethink this?
I think all of these will need their own RFCs for sure.
Okay.
Yeah.
Cool. So look out for those in the future.
Totally.
I want to ask about, speaking of upgrade paths, kind of say someone is just writing their own application and they're like, oh, they get pretty far and like, oh, I need async in here. And so at that point, are they just going to like, happily import async-std and then remap all of their like types to async-std and then it's all going to just work out for them? Or do you think that like, do you also change signatures, say, of various things? But I feel like you must have to.
Yeah. Well, we have had to. For sure, but not as much as you might like think we had to. Yeah, and most of the signatures that have been changed are kind of due to lack of language features. So all the async traits, we couldn't do one-to-one mappings because you can't have async FN in a trait, right? Same for like an async closure, right? So all the streams combinators and all those things, they're not quite async versions of it yet. There's some gotchas there, but and the third one, I guess, is like stuff like mutex, like poison errors don't make sense in an async context because the way panics work is very different. But I think besides that, for most of the code, you could almost write a code mod that adds like replace std with async-std and then add .await for all the calls, and then you're done.
With regard to poisoning, I feel like there's a long-term plan to kind of replace the mutex and std with parking lot somehow, which doesn't poison at all. And so maybe that's a decent dovetail. But also, I want to ask about like, so if you have an I/O, like a file system API, do you try to like have just open and then in the async-std it returns a future, or is there like an open async version?
No, just open, return the future, because it's a separate type. Instead of like having both the synchronous and asynchronous on the same type, we decided to create new types, because it would be a little bit clunky to be like file.async open.await inside of an async function. Becomes like you see the word async everywhere. It's not as nice.
Well, then what's this new type then?
It's called file.
It's file, but it's async-std IO or FS file.
Yes.
Okay, interesting.
Yeah.
Okay, that seems like it makes sense. Let me think. What's the next step for async-std now that features or async await is stabilized and you had a release? I think next Monday you said
tomorrow.
That's tomorrow. That's right. Yeah. So tomorrow there should be we were not going to have this, I guarantee you, ready to be edited by tomorrow. So anyone listening will be like, oh yeah, that's stable by now.
Yep.
And so now that that's done, what do you think the next like steps are?
Good question. Well, it's not done yet. We still we have a bit of a push to go to practically like release this. But from there on out, we have a lot of things that are still marked as unstable that require a feature flag to enable. So our first pass is to like take a good look at that. Like be like, oh, are there any obvious candidates to stabilize? Right? Are there any things we're unsure about and would like more feedback about? Is there any documentation that we need to change? That kind of stuff.
Yeah, how is documentation for async-std? If someone wanted to use it and learn it, it doesn't look very good. Look in your face.
I've spent many hours on it.
Well, that sounds like a good thing, right?
Yeah.
There is some, and people can care about it, it seems, or at least you care about it.
I'm gonna be a bit less modest there, and I'm gonna say our documentation is quite good.
Quite good.
Yes.
Excellent. All right, perfect. It's good to know.
Yeah.
Because people don't want to just like go in there and be like, look at the
absolutely.
Rust doc and it's just signature and be like, nope, I got no doc comments, nothing.
No, we have like examples.
You
for
want
almost
examples? You
everything.
want little hello worlds,
extensive dogs, error types.
fantastic.
All
Good.
yeah.
Good to hear. It's very important for usability, especially in Rust. We value that a lot. That's also, I had a different question. So today, again, at Florian's talk, he mentioned that because of language changes in the future, there's probably going to be a async-std 2.0
Yes.
someday. And can you talk more about what things are you stabilizing in 1.0 that you think would need to change for a 2.0 or might change? Like you mentioned some things in the language like the async FN thing, but what would that actually change about the futures interface?
Right. So I think it might be good to take a small step back and be like, what does a 2.0, what does a major upgrade actually encompass? Right. So breaking change. In our case, using a new dependency, like if future 0.4 comes out, it's not an automatic upgrade. Like that is a breaking change, right? New language features are breaking changes. But when people hear breaking changes, they might be like, oh, it's a completely new thing. I need to rewrite everything. And no, we're pretty much done with the interface. Like these are the details that wouldn't automatically work and your build would break. But we think our upgrade path, or we want the upgrade path to be super clear, right? We're not going to change method names. We're not going to do all these things. Maybe a few. Maybe we realize we've made mistakes. And there's a good chance to change them. But the upgrade path should be essentially, for most people, upgrade the version from 1.0 to 2.0, upgrade your compiler version to the right one, and fix a couple lints here and there, right?
Okay.
And that's it. Like painless.
I think, though, a lot of anything to aspire to call itself std has to worry about version compatibilities where you have two projects, one's on this version, one's on that version.
Right.
So how do you foresee that being a problem in the future?
No.
Okay.
No, not really. Breaking changes are always a question of how do you upgrade. I think if we can do the right communication from the start, which we're trying to do, by the way, and provide good upgrade guides, then we'll see there'll be a small period where people are upgrading, it's a little murky, and then we're upgraded and we continue on.
Do you know of anyone kind of using async-std in a big capacity to test, just kind of to pummel it for a while, run it through its paces?
Well, we've been doing that ourselves internally, trying to be like, how do we stack up, right?
Doing what, though? Do you have test suites, big example applications, anyone using it in kind of production capacity? It's from Ferris Systems, and so is there, it's a company, do they have any clients that they're using it for, or?
I don't know. I'm not part of Ferris.
I see.
Right. But yeah, they do client work with it. I know that much. Okay. And we have lots of benchmarks and pretty hefty testing going on. But as always, there's room to improve. But cool. Overall, fairly confident in it.
Excellent. All right. Well,
yeah.
Is there anything else you want to talk about in terms of if somebody wanted to get involved? What are the best websites or chat channels to get in touch with you on? Yeah.
So our website is async.rs. Which I'm pretty happy with that. Yeah. If you're interested, you can check it out there. Otherwise, we're on Discord. There's links to Discord from the GitHub. I think maybe even on the website. There's people online if you have any questions. You can also hit us up on Twitter. My Twitter is, I can't spell that, so whatever. But we're on async-rs on Twitter. Just, ask around.
All right. Thanks a lot. Anything else you want to say?
Anything else I want to say? I'm just excited.
Everybody is. It's an exciting time right
Thursday. Now. Yeah. No, I'm just very excited for the future of async Rust. I think this is a big milestone, and things are definitely heading in the right direction. And I'm just, All right. Well, cool. I want to see what comes next.
Well, thanks, Yoshua. Thanks for being on.
Yeah.
Great.
Thanks for having me.
See you around.
All right.
Welcome to the Rustacean Station podcast. I am Ben Striegel, not live from RustFest because you aren't here right now unless you're hiding behind that pillar over there. So I am here with Stjepan G.
Stjepan G. Yeah.
G. Okay, Stjepan G. I will never get that correct.
Yeah.
You are currently the maintainer of Crossbeam.
That's correct.
I understand.
Yeah.
Excellent. And so I want to just lead with, why don't you tell me, what is Crossbeam, real quick, high-level overview?
Yeah, a lot of people ask me this question, but I think the short answer is Crossbeam is a library similar to stdsync module, except it's better included. it's like an extension of the StudSync module, which means it includes more of concurrency primitives like lock-free queues, channels. We also have an epoch-based garbage collector, scope threads, things like that.
Yeah, so that's actually quite an old project, I think, originally. So Crossbeam, I think, was Aaron Turin made it many years ago, back around Rust 1.0. I remember reading blog posts about epoch-based garbage collection back then.
Yeah.
And at what point did you get involved?
I believe Aaron started the project in 2016.
Okay.
And he was working on it with some other contributors for a few years, but then he didn't have time to maintain it anymore. So he passed maintainership over to the community, but I sort of stepped in as a leader of the project because it was well suited to my skill set and I was really interested in it, and I had a vision for the project.
Mm-hmm. And what was the vision back then?
The vision, so at that time, it had like a very basic set of primitives like queues, a simple epoch-based garbage collector, which had like a number of flaws. I think even soundness issues. It also had scope threads and a triber stack, which is not super useful. But my vision was to expand the set of primitives, to expand the APIs and make primitives user-friendly. So I really wanted to bring this super complex area of lock-free programming to the wider audience. Like, I wanted anyone to leverage the power of this weird advanced stuff without much.
I think there's a lot to unpack here, so let's try and take it one thing at a time. Is it even possible to give a brief overview of what epoch-based garbage collection is? Like, I thought, this is Rust. We don't even want garbage collection. Why? What is this?
It's hard. Yeah, okay. I'll try to be brief. So the thing is, in concurrent programs, like in parallel programs, when you have multiple threads, and say you have a queue and you push things into the queue and pop things out of the queue, and if the queue dynamically allocates a node for each element inside the queue, at some point when you pop stuff out of the queue, you will have to deallocate that allocated slot where this element was stored. But the thing is, a lot of threads could be accessing that particular slot allocated on the heap, trying to see if there's something inside it. But if some thread concurrently deletes, like attempts to destroy that heap allocated objects, then other threads are not allowed to read from it because, it might be dead. So what we do with epoch-based garbage collection is multiple threads cooperatively can decide when heap allocated objects will never be accessed by any threads anymore, and only from that point on we are allowed to destroy those objects.
So I think a different way of saying it is we already have, in Rust today, we have ARC, sync ARC, which is
correct.
Essentially, it's reference counting, which is a form of garbage collection. And so you can opt into this if you have, for example, some kind of dynamically allocated thing being read and written to from multiple threads. And so the reason that you need this is that Rust's normal ownership rules kind of work in like a tree-like hierarchy, very static. But thread access patterns are very dynamic, so that just doesn't work. And so you need something.
So
like
arcs would also work, but the thing about arcs is whenever you clone an arc, you have to update some kind of atomic reference counter. And when you stop using an arc and you drop it, you have to decrement this reference counter. And if you have a lot of threads constantly incrementing and decrementing that counter, that's a lot of overhead. That makes things very slow. So with epoch garbage collection, we avoid all that overhead, all that contention on like single reference counter. We sort of like localize those updates among threads so that each thread has, like, in the common case only like updates its thread local storage. Like a way of thinking of this is perhaps like instead of having this single shared atomic reference counter, we distribute it over threads so that each thread only updates its thread local.
It's kind of sharded among threads.
Kind of, yeah. You can think of it that way.
And then the super high level is if you use an arc, maybe you would benefit from a lockless version of this kind of shared memory primitive.
Yeah, that's true.
But at the same time, there's got to be some kind of drawback to this, right? There's always a trade-off with these kinds of things. And so when would you not want to use this and prefer an arc instead?
Well, the trade-off is that memory deallocation is deferred. So, like, if an object has to be destroyed, it will be destroyed at some point in the future, which means we might accumulate a lot of garbage data, which is ready to be destroyed, but it,
It's kind of the classic garbage collector trade-off where you have reference counting, which eagerly deallocates, and you have a tracing garbage collector, which does not. And they both have their advantages and disadvantages.
Yes.
But,
so the main drawback is increased memory usage.
Could you compare it to, say, a concurrent garbage collector like that Java might use, for example? Do they use lockless epoch-based approaches for their thing?
It's different because in Java uses a tracing garbage collector, which means it will it knows where pointers in the memory are. And from time to time, it will trace those pointers to see what objects in memory are still reachable and alive. With epochs, we don't do that. We use a simplified version of that.
And you mentioned your background made you well-suited to understanding this problem. It seems very thorny, very subtle. And so what is your background?
I did a lot of C++ before. And before getting involved in Rust, I did a lot of research on concurrent programming and like lock-free data structures. I dabbled a lot in lock-free skip lists, and I spent like months and months developing my own skip list in C++, and I wanted to transfer that knowledge over to Rust.
Okay. Did you actually end up writing a skip list in Rust?
I did write a lock-free skip list. The thing is, it's almost done, but we never published an actual version on Crates.io. We will get around to it someday.
And then as far as crossbeam is concerned, it's not just this epoch-based thing. It also involves like its own channels. So could you not use the standard sync channels with a crossbeam pointer? Or I guess I wouldn't call it a pointer. So it's not quite... Is the interface similar to arc, where it's like arc : new, give it some data, and then magic takes over, or is it more involved than that? How would I initialize some data and put it in the system?
You mean inside channels?
So one question I have is in the standard sync module, there's both arc and there's channels, but I don't think you need channels to use arc and vice versa. You could use them independently. Is that true for crossbeam? Could you use the standard channels with crossbeam's types and vice versa? Or is it just that you want to provide alternatives that are faster in your way? What are the benefits of using your own channels?
They are complementary. Like channels in particular in crossbeam are pretty much strictly better than channels in the standard library in pretty much every way.
Okay.
Like they are more flexible. They are MPMC rather than MPSC channels, which means you can clone receivers. They're more efficient. There is also a selection interface, which means you can select over multiple channel operations. I even wrote a proposal to include crossbeam-based channels into the standard library, which might happen someday, hopefully.
Is the RFC still open?
This is still, like, there is an open proposal. I even wrote an implementation, which can be just copy-pasted into the standard library. But it is up to the library team to make a decision of whether to include that.
Mm-hmm. Okay, interesting. And then hopefully we'll see that someday if it actually, like, are there any trade-offs? Like you say, it's all better. Is it like more memory usage, or it doesn't work as well on...
No, there are really no trade-offs.
It's kind of, you just made a better version.
Yeah, pretty much, yeah.
Is there a lot of research here on terms of like lock-free
there was a ton
data
of
structures
research.
and
I spent like years working on those channels, and channels might seem like a trivial thing. It's just a queue after all. And,
Just a queue.
Threads can push and pop data out of the queue, in and out of the queue. But as soon as you add a selection, if you want to support these select blocks, then that complicates things so much, and things get really, really involved. And I based crossbeam channels on work by Dmitry Vyukov, who is working on the Go runtime. And he made a proposal to improve channels in Go and wrote this document. It's called Go Channels on Steroids, and it's a really good read. So I basically took his proposal and re-implemented it in Rust, and then also expanded it a little bit.
Excellent. So I know one of the things that the standard channels are missing is kind of nice select interface. Like maybe there's a macro, or was at some point, I forget.
There used to be a macro in the standard library, but it had like its own quirks. There was also select struct for dynamic selections, which means you don't have to statically decide which channels operations you are selecting over, but you can dynamically at runtime add those cases to a select. So that interface in the standard library was always unstable, and the API was unsafe, which is unfortunate.
And is it safe, the version in Crossbeam?
Yes, in Crossbeam it's completely safe.
Is it also a macro, or is it a method?
There is a convenience macro,
Okay.
which is really nice to use, but you can also dynamically add cases to select using the select struct.
Wonderful. So very cool. What other parts of Crossbeam are there besides the channels? You mentioned some things before, I feel like. The scoped threads, for example.
Yes, we also have scoped threads. There are also lock-free queues, which are sort of like channels, but more lower level. So if you want to build your own channels, you would most likely use those queues. We also have work stealing decks that is used by Rayon and also used by async standard. Those decks are very useful for building your own schedulers and things like that.
You said decks?
Deck, yes, like double-ended queue.
Oh, okay, yeah. I was trying to think of like, well, yeah. I usually say like DQ, but that's definitely not how it's pronounced. There's no good way of pronouncing that word.
Yeah. We also have some atomic primitives. There's this thing called atomic cell, which is similar to types in the standard library called atomic usize, atomic U32, atomic I32, and so on. But those in the standard library are not that convenient because they require you to specify memory orderings, whereas atomic cell just works like without specifying memory orderings. But also you can put like vectors in atomic cells and arbitrary kind of data.
Is that kind of, I know there's a crate called once cell that uses standard sync once to initialize things exactly once. Is that kind of a complement to that or a replacement for that?
It's different. So once is for initializing data once, whereas atomic cell is like a cell, like the cell type from the standard library, except it's thread safe and you can update the contents of that cell as many times as you want, so not just once.
Okay. When you took over the project, you said there were some things that were unsound about some of the APIs?
Yes. There were some soundness issues in the epoch-based garbage collector, but I really won't go into that because it's super subtle.
Do you feel like you've fixed those since?
Yes, those have been fixed.
Okay, how do you even prove that kind of thing? I mean, I'm not going to ask you for like an actual proof, but like for your own satisfaction, when did you feel like, okay, this is right now?
I don't know. It's a lot of work and looking into the APIs and trying to find failure points. We also have this contributor whose name is Jihoon Kang, and he is a PhD researcher in Korea, specifically studying memory models and lock-free programming. And he made a proof of the correctness of our garbage collector.
Very cool.
Yeah.
Excellent. That's great to have, because I know back in the day,
Yeah.
it was a big question. Like, well, we'd like to maybe include crossbeam in STUD one day, but we're not actually sure if it makes any sense. So it's fantastic to have that. I wanted to ask about its use in rayon. So rayon uses the queue, the underlying queues for its own purposes.
Rayon uses DEX.
The DEX.
Work ceiling DEX for balancing the workload among its own worker threads.
Cool. So anyone using rayon is currently using crossbeam.
Yes.
Because rayon is just fantastic. It's an
Yes.
exemplary library. And then you also mentioned async-std is using crossbeam. I saw today up in the presentation that Florian gave about async-std being faster than crossbeam even somehow. And then Yoshua told me to ask you about performance in some way, and said that you're working on performance very heavily. Do you want to talk about that?
So in crossbeam, we have our own channels, which are based on crossbeam channels, in particular the bounded version of channels in crossbeam. So the performance advantage of crossbeam channels are in that context switches on asynchronous tasks are much lower overhead than context switches with threads. So if you're sending a lot of data between different tasks, we can context switch between them much faster than with threads.
Excellent. And there's still MPSC or MPMC.
Yeah, those are also MPMC.
Multi-producer, multi-consumer.
Yeah.
Fantastic. And is it the same kind of, is it all the same implementation underneath for both threads and tasks, or is it a totally brand new thing that you had to write to support futures?
So the underlying concurrent queue is the same as in crossbeam, but the instead of notifying threads when send or receive operations can proceed, we have to notify asynchronous tasks and use wakers for that. So that part is different.
Okay, cool. But other than that, it's all shares all the same code, benefits from all the same bug testing
Exactly,
and proofs, that sort of thing. Excellent. Okay, so is there anything else you want to talk about with regard to async-std or crossbeam, or what's the future hold for it?
These days I'm mostly focused on async standard and like asynchronous programming in general. With regards to crossbeam, we have been at like 0 point something releases.
0.9999999, where it's like you want to get to 1.0, but you're not quite there.
Yeah, that's with async standard, but also crossbeam has been at 0 point something for way too long, and we really gotta push it over to 1.0.
What's required for that?
Not very much, actually. Just maybe some small fixes, but it's ready for 1.0 for sure.
I would love to see a library like that reach 1.0, these foundational sort of libraries. Is there anyone, if someone wanted to help with that, what would you say? Like, was there a chat channel they should see you on, or a forum?
We have a Discord channel. We also have a GitHub.
A Crossbeam Discord channel.
We have a Crossbeam Discord channel, yeah. So contributors are welcome. Also at this RustFest during Impl Days, I have a plan to work with some few folks on Crossbeam.
Fantastic.
Yeah, so maybe we'll try to push it over.
Where would they find the link to that Discord? Or
it's in the README, yeah.
Okay, in the README for Crossbeam.
Exactly,
Great.
Yeah.
Fantastic. All right. Well, thanks for coming on. Thanks for talking about it. Hopefully we'll get more awareness of Crossbeam and make things stable and great for Rust.
Of course. Thank you for having me.
No problem.